Thank you very much. We had some audio difficulties. Today's session is about Project Jacquard. My name is Ivan Kuprev, and I am a technical project lead for this project. I started this project at Google about 2 years ago. And today what we're going to do, we're going to talk about 30 minutes about Project Jacquard. I'll tell you the history of the project, what we try to achieve, and show you some of the videos of how we produce this technology. It was the future and products we're building here. One of the products is here already hanging out, and hopefully it works. And after that, in 30 minutes, you will have a chance to play with working demos in front of you. I will show you a sample of the work. We'll have our textiles and everything ready. Right? Okay, cool. And we have two members of the project here, Shiho and Munye, and they will help you to explain after the presentation how things work and what it's about. So let's start. So the fundamental vision behind Project Jacquard is a technology which can connect things and information. And it's coming from observation that, our access to technology being, computers, now being mobile phones, and as we go into the future, more and more things can connect to the internet. You can provide access to information not just from mobile phone on the watch, but from objects around us. And the vision has been formulated many years ago, from 90s and from 80s. People were thinking about ubiquitous computing, and we're now taking this vision to the reality. In Project Jacquard, we're focusing on clothing. So we are interested to connect clothing to the information and provide you access to information through the clothing. And the reason we're interested in clothing is because recently there is a fascination of the public and the people with wearables. Everybody's interested in wearables, but wearables are things you wear on your body, like like a watch or a bracelet. We would like to take a next step and embed wearables and technology into things you wear anyway. And so you don't buy a wearable, you buy a piece of clothes, and that has information built in. So traditionally, in the history of clothing, technology was mostly focusing on enhancing style or comfort of wear. It would make something like Gore-Tex, which protects you from rain and allows your body to breathe, or creating new materials such as nylon to make it more beautiful and give different appearances. However, in recent days, people consider access to information almost like a universal human right. Everybody wants to be connected at all the time, every day, and people spending on mobile phones and trying to access all the time. That's how a lot of meetings I go to, that's not how it looks like. So how can we provide them access to information without distracting them from the world around us, so they can still focus on things around them? So in case, another thing is that people also need access to information in the work environment where they can't use the phone. Like a doctor would pull up the phone during the operation. And so we don't want this to happen. So people need to be access to the information in the work environment through things they already have with them. So in this case, we think about Jacquard as something which adds information as a new key feature of the apparel. So your apparel is going to have a color, your apparel will have the weight, the house will have a pattern design, but it also will be able to give you access to information. So think about it as a new form of zipper, a new form of button, a new form of things you have on your apparel anyway, something which gives you information access. And let me show how it works. So this is one of the earliest designs we built, and I'll show you, just to give you a glimpse of what we're trying to have in mind. This is not a product, this is a early prototype. This is a jacket which we made, which can sense where you're touching it's on a sleeve. As you move your finger or hand on the sleeve of the garment, the mobile phone can see how you're touching and can recognize the gestures. So these gestures can be mapped to the functions. So in these applications, you're running the applications, you can select a gesture and select a number. And by selecting, so this is some non-random number, it's actually a real number. And you select another gesture and connect it to the Uber to call a cab. All right. Now you can turn off the phone and put it in the pocket somewhere or in a bag. And then by making a gesture, you can make a phone call. And by making another gesture, you can call it Uber. So this was a very early vision of how kind of we can build interfaces which allow to invoke information, invoke interfaces directly from the clothing without using the phone. Now, through design of the Jacquard, we thought that the most important thing is that we didn't want people to wear a gadget. People don't like to wear gadgets, right? So one of the biggest complaints about the wearables over the last years is that they're not fashionable. They don't look like a fashionable item. They all look the same. They feel the same. They feel like you wear a piece of plastic on your clothing. So we spend quite a lot of time to think, how can we take it to the world of fashion and not to the world of consumer electronics. And this is kind of our vision. So technology has to be woven into your garment, to become part of your garment and part of your life. And the first design, inspiration comes from this observation that if you take a look at the capacity of touch sensor, such as you have in the mobile phone, is actually a grid of electrodes on a glass. And the structure of the textile, of a woven textile, is almost the same as it's also a grid of the yarns going left and right. So if you replace some of the yarns with conductive yarns, you can weave capacity of touch panels, touch sensor, gesture touch sensors that you have in the computers and mobile phones, but it's going to be a woven textile sensor, which can behave and act exactly like the textile sensor. It can sense your gestures, it can sense your information. But you can weave sensing, you can weave connection, you can weave computing into the textile using standard equipment. But it's not just a normal sensor. It doesn't come in 2 colors or 3 colors. It can come in a variety of colors and materials. It can come with a silk, it can polyester, wool, anything you want. And when you make an object out of this textile, such as a garment or a couch, you will not think about it as a wearable, you will think about it as a garment you wear. And you don't think about it as a technology. And that's the vision behind the Jacquard. Now there's billions of garments made every year. So we have to think about, actually there's a number. So in 2012, 19 billion garments were made and only 220 million smartphones were made. So Google is not in the business of making garments. We don't want to manufacture every single garment in the world. What we would like to do, with like technology, which we can provide to manufacturers of clothing, we provide to people who make textiles, and then they can manufacture themselves. Therefore, we have to come up with principles and manufacturing principles where we can manufacture these interactive textiles at scale using existing production facilities, such as this one. This is one of the small mills we're using in Japan, which actually manufactures textile for sale at the market. So designing technology which allows to weave interactive fabrics, interactive yarns, and make it on a scale was one of the main goals of the Project Jacquard, to make it sure that it's done by us. Now, it's a very aggressive process. Making textile is hard. And actually France, Project Jacquard actually comes in honor of Marie Jacquard, which is a French inventor, invented loom, Jacquard loom. There's a lot, in Lyon, there's a lot of facilities to produce fabric and textiles. And if you go there, you will see that just weaving fabric is not enough. There's also after finishing process where they do crazy stuff with fabric. They burn them with open fires, they submerge them in liquids, they pull them, then stretch them, press them. So normal electronics could not withstand all this crazy abuse you have at the textile factory. So we had to go and design our own yarns to withstand it. Another problem we have there is that this is a catalog of colors which textile designers use when they think design by textile. You see how many colors are there. But if you take a normal conductive yarn you can buy from the store now, that's the only color you get is gray. And that's just not going to work with the creative community which is going to create clothing. So we had to go design our own yarns, which can both withstand very harsh manufacturing processes. At the same time, they can come in multiple colors and multiple materials, which brings design freedom to designers and apparel makers. And these are examples of the yarns. This is the yarns here. I'll talk about them a little bit at the moment. So we had to build a little manufacturing facility. We do this in Japan. And this is the structure of our yarn. Even though yarn looks very thin and very normal, actually it's a complex braided structure using the same principles which are used to design kimono lines and kimono yarns tradition in Japan. It's a braided with multiple filaments. We're using about 12 filaments of polyester, silk, or cotton, anything you want, and there's a conductive core inside. The yarn is modular. It's very important because we want to create qualities of yarn which are required for our applications. And so we can replace the outside layer with other materials. So it can be silk versus polyester versus cotton versus wool, and go in different types of clothing. And also we can replace the core, which is right now conductive core is made of normal metals, but it can be something else. It can be stainless steel, can be polymers, and anything you like. Or it can be replaced with different sensors. It can be stretch sensors, with photo sensors, photo resistors, and so on. And let me show how it actually made, how yarn is made. So it's a complex process. This is a braiding machine in Japan. That's how it comes up. So that's the way it comes out as a real yarn, and then it gets wrapped around, and then very analog, very analog. So this is yarn we're making. So one of the members of my team actually we used to work at Motorola, and if you go in the factory, Motorola factories, or if you go to mobile phone factories, every minute there's one phone comes up from the line, production line. And he came to the yarn factory, and every minute we have about that much of yarn coming out. This is like, wow, this is crazy. How are we going to scale this? Anyway, but this is the question. That's how big differences there are between consumer electronics and producing of soft goods. So once we get the yarn, we can weave them in a variety of shapes. This is kind of the make big, large surfaces with the conductive grids. But then, how do you connect them to electronics? So connecting them to electronics is another big problem. And this is, we tried this approach. Then we tried this approach, also didn't work. Try this. And this is better, because here what we can do, we can pick up some of the elements of the yarns and connect them to electronics to make sure it's connected. But all of that didn't work. None of them would scale into industrial production. None of them can be made in the real world. So what we did, we went back to the principles of designing textiles, and we come up with the size of the grid like this, so only this size is interactive. And the yarns then go on the second layer and come up from the back and float around the surface of the textile. So now you can put machinery here, which allows you to connect our yarns to electronics. So this is, you can raise it up, put machines, and then you get something like this. So that becomes a connector, which is then can be connected to the electronics and made into the yarn. Let me show how actually we make our textiles. So there's also a small factory run by very small craftsmanship people, but they are producing textiles for large brands and large production. Then you can see a capacitive touch panel, which we do this coming out in here. So the beauty about weaving electronics, the beauty about soft goods and textile is that it can come up with multiple colors and multiple designs. So this is our capacitive touch panels, gesture panels, which allow to check gestures. And you can see they can have different shapes. They can come out, can be combined with the design of yarns. This is our capacitive panel, and it's combined with the design of textile. It's can be used with wool, pretty transparent like organza. It can be completely invisible, so you don't even see where the touch panel is, or it can be stretchable like for athletic apparel. And it also can be made as big as you want. So this is all woven, these are big capacitive panels. So this gives you this amazing flexibility and create sensors, any size, any large, any form you like, and then take them into making the products. Now you can connect them to electronics, connect to mobile phone, and that becomes your interactive textile. Now, as I mentioned before, Google is not trying to become a parallel company. And the core goal here is to collaboration and co-creation with apparel business and apparel factories. And then we're actually going to show our first product, which is here, which is a Levi's jacket, which we're going to launch in the market next year. But before going to Levi's, we wanted to test if you can actually make anything interactive by the real tailor. So we went on, because we think about Jacquard as a platform. What we provide is textile structures, connectors, electronic, wireless connectivity, mobile ecosystem with application which allows you to use Jacquard sensors. And then it's used by people and services on the background. All of that we want to provide to the apparel makers, to the factories, either it's in Europe or Asia or anywhere in the world, and there they can make, now it doesn't matter how big or small you are, you should be able to use this ecosystem to create your own conductive textiles and your own smart apparel. So the first step was to go to work with the tailors. We went to the United Kingdom, we went to the Savile Row, which you know is a place where all the high-end suits are made by the tailors. And we gave a piece of textile to the tailor and asked them to see what kind of jacket the person can make with our textile. So this is the tailor there, and of course we didn't just drop it on him and say like, here, go ahead and do it. So we explained them how it works, but then we pretty much tell them like, use your imagination, use your thinking, how do you make it, and how do you make a garment. And this is what he came up with. It's a handmade process. Tailoring has been the same for the last 200 years. It was invented actually in Savile Row. They're still using the same technique. It was surprisingly, but because our technology was a textile, our technology was not a gadget, we gave it to him, they could treat our sensing technology the same way as they treat any piece of textile. So the language of conversation with them is the same as they have with normal technology, with normal textile. So they're not assembling a garment, they're not assembling the wearable, they're sewing together, they're crafting it. And this is very important because again, our goal is not to make our own garment, but to empower the industry, empower the apparel industry to take it to the wearable world, to take it to the information world. And now you see the same example, he swipes the sleeve and make a phone call. So this is a garment that's here, this is a jacket. This is the first Jacquard jacket done by the real tailor. So this is how we think about it. So like you think about it, 85% cotton, 15% Jacquard. We were looking for the first industrial partner to take it to the market. And the first partner which we found was Levi's. And Levi's is a company which next to us in San Francisco, they just a few 40 minutes away from Mountain View headquarters where Google is. And when we came to them and showed them this technology, the immediate response there is that we want to create a jacket for urban cyclists. Because Levi's has this line called Levi's Commuter, which is cycling jackets, cycling clothes. And they said the really common need there is that when people on the bike, people biking around through the city, through the traffic, they cannot pull out the phone and find out what's the next direction, who is calling them, share the location, tell them that we're going to be late, control the music. You just cannot do this. You're going to drop the phone or fall off from the bike. So combination, this technology was perfect combination, perfect kind of implementation for this line of garments. So this is a vision of how the recent kind of video we put together with Levi's, which shows how it can be used in the real life. So this is a jacket. So you can make a gesture on the phone to give him next directions, to tell him where to go next, because he forgot where to take a turn. He can share the location with his friend to say he's going to be 20 minutes late. And he can control his music to change the truck. You know, he can dismiss his phone from his boss, because he can see on LED which flashes on the sleeve who's calling him. And that's kind of our vision of the product which we are working on right now, which the first version is here. The first time we're showing outside the United States. So the garment, so as we start putting this Jacquard technology in the product, we start understanding there's a lot of challenges to actually make into the product beyond the research prototype. So we have a garment here, and again, one of the biggest questions we have is that how are you going to charge this garment? How are you going to add add power? Are you going to ship this garment with a cable? And we didn't want to do this. So we separated the battery in a separate unit with LED and haptic feedback, and put it inside of and that you connect to your sleeve. In this case, you can take this and connect separately. That's how it looks on the jacket. So it's bent around it. This is an LED, haptic feedback, which looks like a classic Levi's button, so it follows the same style of the Levi's. We designed a custom connector. As we learned from Apple, if you connect connectors, they connect the world, and then you can lock it to the attach to the sleeve, and you can charge it from any mobile, from any device, from any USB charger, without needing a cable. We also provide mobile phone applications. This is an early prototype mobile phone applications, which allows you to configure your jacket to do exactly what you want. Do you want it to be a navigation assistant? Do you want it to be a music assistant? Do you want it to be control your phone calls or incoming phone calls, send the messages, play the game, or do anything else you want, or connect other services? And I'll talk about this a little bit later. And finally, most of the services are living in the cloud. So right now, for most of the services we're using on the Jacquard, you don't even use phones, applications on the phone. You connect directly to the cloud, and the phone is only used as a link to the internet. And in the future, I think we can get rid of the phone altogether and connect to the internet directly from your garment. So I would like to stop and talk a little bit about the design challenges, creation challenges which we had when we're building a smart garment and digital garment. The reality is that, as I mentioned before, we don't want to create a gadget, we want to create a fashion item, and there's natural tension between fashion and technology. For example, this was the first design of our conductive area, our sensor. And you can see it's very visible. I loved it because it's visible, you can see it clearly. And Levi's fashion team came to us and said, this is not denim. Denim doesn't look like this. Denim doesn't have this kind of things. I said, all right, we're going to do it differently. We're going to make it completely invisible so you don't see it. But now nobody can touch it. Nobody knows where to touch it, where the interaction happens. So working with our craftsman team in the denim craftsmanship, some of the best denim makers in the world in Tokyo, we came up with a new weaving techniques which create a completely new look of the denim. So here the interaction panel is half visible, half invisible, and to make it visible we're using a weaving artifact which is called mispig. We're missing one of the wefts, and you can see the white line coming on top. And we're repeating this across the line. So in some sense, we are drawing on the surface of the denim with these techniques to show where the area is. And they were very happy about it. Another important thing is that in fashion, product comes in multiple sizes, from extra small for women, from extra large to men. In some countries it is extra large. And then, so technology has to fit all the sizes. So we design our tag to be flexible and bend around the cuff so it can fit the size of any cuff of any size. This is, by the way, the first one you can see it here. It's flexible. And by the way, this is the first flexible piece of electronics which actually released on the market and actually produces it. And the design, by the way, was inspired by design of the classic trench coat and a cuff strap, which you can see in the classic trench coat. Now it seems very simple, but we had to go through a gigantic list of design solutions to make it just right, to make it flexible, to make it thin, to make sure that they're all connected together. The only common thing between them is the Levi's button on the top. This thing doesn't change. Finally, another issue there is that our garments and our clothing is extremely robust. You can drop your garment on the floor, you can walk on top of it, it doesn't break, it doesn't scratch, it doesn't do anything like that. Now you don't have to prove these days that the garment can be, you can need 2 horses to pull it apart to make it reliable, but at the very least you have to be able to wash it. So the garment has to be washable. Now surprisingly, we don't wash our jacket that often as I thought. You don't wash them too much, but at least they have to wash about between 10 to 20 times during the life of the garment. And our first test was quite disastrous. It would break after a few washes. So we had to go back and apply serious scientific research, working with the metallurgists and universities, figuring out why it breaks, where it breaks, what exact specific alloys we have to use to make it working. And the recent work suggests that we can actually wash our garment multiple times without breaking. And final point here, again, so I keep repeating this point, but it's very, very important, is that we don't want to make our own garments. We don't want to go in garment manufacturing business. Our goal here is to empower industry. It means Levi's has to make its own garments using our technology. So we had to go to Levi's and have them to start production. So let me show a quick video which shows the path of the garment from the yarn which we make through weaving factories which we use around the world You can see this is the same machines we weave denim for Levi's, for normal products. And this goes through the burning process where they burn off excessive fiber, it collects there, and then being shipped to another factory where it's made into the clothing. It is the same process which is used to build a real garment by the Levi's, and the same processes such as industrial wash. We had to add some control facilities where people can check if it works. It doesn't work after the conduction of the jacket, but at the end of the day, this is still a garment. You don't buy a gadget, you don't buy a wearable, you buy a normal gadget garment, which is, by the way, has smart capabilities inside. So we are planning to launch this jacket in spring 2017. This VivaTech is the first time we're showing it publicly. Actually, not only outside of the United States, and publicly, we will show you the functioning version of the garment today. And we would like to go further from that. We don't want to stop on Levi's. We're not doing this for the Levi's, because we want to build an ecosystem and platform for designing any interactive garment, any digital garment you would like. So there's two ways it can scale. First, we can change the functionality. By using our app, Jacquard app on mobile phone, you should be able to add other functionality you want. For example, it can be messages in the call for mobile phones. It can be Google services, such as Google Map, Google Play, Google Assistant, Google Calendar. Or we can invite third parties, such as Spotify and Strava. We already integrated their functionality into the garment, so you can access your music from Spotify or control your ride from Strava. Or we don't want to open that for the third parties, for the custom developers, so people who can develop their own functionality for the smart garment run on Jacquard, and we will provide APIs which allows you to do this. And of course, we want to go beyond just Levi's jacket. We would like to go to athletics, we'd like to go to business, we'd like to go enterprise and uniforms. And actually, just recently, before coming to VivaTech, we announced our second collaboration with a company called Cintas. A company, Cintas produces the biggest uniform maker in the world. They're making uniforms for all sorts of industries, and we're focusing on two directions. For the healthcare, how can we make healthcare safer and more efficient with the smart garments, and also industrial enterprises where the amount of liabilities people pay, but it's $65 million are spent every year in America to pay worker compensation for injuries and different work-related problems. So how can we reduce work-related injuries, make workspace safer and more efficient? That's how we're exploring right now with the Cintas factory. That's Project Jacquard. And if you have any questions, I'm happy to answer the questions, and then we can move to the demo. When the API will be published to the developers? Yeah, well, unfortunately, I cannot commit to the date, but I think our plan is first to launch the garment, which opens in the spring next year, and then we will announce plan for the API release. I mean, there's a chicken egg problem. You can't really announce API until you have some garments on the market, right? So we want to first get the garments, then we announce API, then people will be able to buy the garments and work with the API. So it's one after the other.
So, if I could ask, so far you were talking about linen and so on, so what all the materials could be used with this kind of jacquard? What materials exactly could be used? Is it unlimited to all like wool and cashmere and so on, and do you plan to extend it further, or what's your policy on that? Thank you.
So the choice of materials depends on multiple factors. Right now we use polyester and silk mostly, but the choice of material depends on, and in theory our yarns can be produced with any material. We can use wool, we can use any sort of polyester, we can use cashmere, we can use medical grade fibers, anything you like. But the choice of materials depends on first of the application. So every type of textile is made of different types of materials, and also different brands that request certain things. For example, European brands would like to have their materials made in Europe. And then The second thing is that manufacturing of textile, specific type of textile, require different type of materials. The treatment of textile after manufacturing can be very aggressive, such as high temperature, so you need to choose materials which don't degrade by those things. But theoretically, we can use almost any materials to make our textiles and our yarns.
Thank you. Actually, I have two questions. The first one is until right now you are only making the long sleeves for jacket. So in the future, especially like I'm from China, in Canton it's very hot. Not everyone can wear a jacket every day. So are you going to make, for example, pants or like other kinds of wearable clothing? And the second question is about the material, the safety of the material, because for example, just now you are putting this. Next to that, they have some influence on this phone. So is there any other problems for future? For example, past the safety door or something that will have some influence. Thank you.
Okay, the first question: are we going beyond garments, jackets? This is we would love certainly to go beyond jackets, but that's really not up to us because we don't make our own garments. It's up to the brands or companies we're working with. So that's a question of collaboration. Second question of safety. There's two levels of safety. One level of safety is that is it safe for the humans? The second question of safety, what you allude to, is that is there an interference with other devices? And we are right now going through the qualification studies for the second questions. For the first questions, there is no reasons to worry about safety. I think it's safer than a mobile phone because the quality, the power levels is really, really low. You can't even detect the touch. So for the human body, there is no problem. But you can play with yarns, see the textiles, try them, and see the demo. So thank you very much.